Okay, we're back for part 3. There's going to be a lot of steps involved here, but they're not steps that you haven't seen before. We're going to practice doing method 3 of finding the decimal equivalents of fractions. Method 3 is plain old converting. Converting something means to change it. So we're going to do the mathematical long division involved in changing a fraction to a decimal. So here goes. Our first fraction is going to be 3. Step 1 is going to be to divide. You're going to divide the numerator by the denominator. Divide the top by the bottom. Now that's going to look funny when you first do it. You're going to put your little division house, and you're used to the larger number being on the inside and the smaller number being on the outside. But this is different. We're going to take the numerator, goes inside. The denominator goes outside. And I know you're thinking, that'll never work because 5 can't go into 3. 3 is too small. I know that. So, we're at step 1. We just set up the division problem. Step 2, add a decimal. Take your decimal, move it to the top of your division house. And we're almost there. And then add a 0. I know that 5 can't go into 3 because it's too small. We added that 0 because I know 5 can go into 30. So far, I haven't changed the value of what was in the house. 3 was in the house. All I did was add a decimal, add a 0. It's still 3. 5 goes into 3 no times. I know that, so I'm going to go ahead and put my 0 there. But 5 goes into 30 6 times. 6 times 5 is 30. 30 minus 30 is 0. Now I know that 3/5 is also equivalent to 6/10. We also used this example or something like it in the previous 2 methods. So as you can see, it does work. Okay, we're going to do a couple more of these. This one was a pretty short division problem, which I'm sure everybody's going to do fine at. It seems like the longer the division problem gets, the more complicated we think it is, but that's not true. Remember, division is the same 4 steps. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. As long as you keep doing that, there's no way you can get it wrong. All right, our second fraction is a 4th. 3/4. And we're going to do the exact same thing. I'm going to set up my division problem because I know I'm getting ready to divide. I'm going to put the numerator inside, the denominator outside, so it's going to look weird to me for a little while. I'm going to add a decimal, bring that decimal up, add a 0, and then I'm going to start dividing. 4 can't go into 3, so it goes into 3 no times. 4 goes into 30, though, 7 times. 7 times 4 is 28. 30 minus 28 is 2. Now here's the thing when you're dividing to make a decimal. You don't ever want to have remainders. Decimals don't have remainder. Remember me saying that decimals work just like money. Have you ever had someone to give you 50 cents remainder 2? No, I don't think so. Decimals work just like money, and there are no remainders in money. So you're going to try your very best not to end up with a decimal. So in order to do that, I'm just going to keep adding zeros. Now I can bring that down so I can keep on dividing. 4 goes into 20 5 times. 5 times 4 is 20. 20 minus 20 is 0. Now that I don't have a remainder, I can stop dividing. Now I know that 3/4 is equivalent to 75 hundredths. Now I want you to think about something for a second. Decimals really do work just like money. What if you had 4 quarters? What if I took 3 of your 4 quarters? How much money did I take from you? 75 cents. 3 out of 4 is 75 hundredths, or 75 cents. And as you can see here when we did the math, it really does equal 75 hundredths. All right, we're going to do another one. Five eighths. 5/8. Okay, we're going to start off the same way. We know we're getting ready to divide. Numerator goes inside. Denominator goes outside. I'm going to add my decimal, bring it to the top, add a 0. 8 goes into 5, 0 times. 8 goes into 50, 6 times. 6 times 8 is 48. 50 minus 48 is 2. Remember, I don't want to have that remainder. So I'm going to add a 0 so I can bring it down. That way I get to keep on dividing. 8 goes into 20 2 times, because 8 times 2 is 16. 20 minus 16 is 4. I don't want to have a remainder, so I'm going to keep on adding zeros so I can keep on dividing. 8 goes into 40 5 times. 5 times 8 is 40. 40 minus 40 is 0. Now I don't have any more remainders and I can stop dividing. That tells me that 5/8 is equivalent to 625 thousandths. Now I want to show you one more example, just so that when you see it, you don't think something's wrong. We're going to take a look at a repeating decimal. A repeating decimal is what happens when we do all the division and then we get a number that no matter how many times we divide, that same digit keeps on repeating, okay? So what you're about to see is a repeating decimal. Let's say I asked you to take the fraction 1/3 and I want you to convert it or change it to its decimal equivalent.